Okay, now we want to talk about climate change. And climate change just means that the climate is changing. So it could be getting too hot, it could be getting too cold, it could be getting too dry, it could be raining too much. So all of this is called climate change. And so what we think is that humans are somehow affecting the climate. So the first thing I want to mention is the climate has changed in the past. So this is shows the how the climate of the Earth has changed over billions of years. And so you will notice that at certain times, the average temperature of the Earth has been hotter, and then at other times, the temperature of the Earth has been colder. So during those cold spells, that's when the ice ages have occurred. And so we've already talked about this when we talked about the ice ages. And we mentioned that several times in the geological past, there have been ice ages. Now, currently, we are in a interglacial period. So for the past 1.6 million years, we have been experiencing ice ages. And so these ice ages have been means that sometimes the temperature has gotten cold enough that ice sheets have covered North America and Europe, and then in between these cold spells have been warm spells. And currently we're in the middle of a warm spell. But it's been for the past 1.6 million years, the climate has been getting colder and then warmer and then colder and then warmer again. And right now we're in between cold spells here in North America and Europe. So what is it that causes global warming? So there's a lot of things that can cause global warming, and you'll notice that these explanations are the same explanations that we used to what triggered the ice ages. Okay, so the first one that we want to mention is going to be greenhouse gases. So we think that this is the primary culprit in warming the planet's atmosphere is going to be greenhouse gases. So carbon dioxide and water are both greenhouse gases, and they act like a blanket, and so that light coming in the form of ultraviolet light. Now, a lot of that ultraviolet light is going to be stopped here in the stratosphere, but some of that ultraviolet light is going to make it to the surface. It's going to heat up the surface of the Earth. Then the Earth is going to re-radiate the energy in the form of infrared light, heat. So that infrared light is trying to get back into outer space. But greenhouse gases such as water and carbon dioxide and methane act like a blanket, and it keeps this light from escaping into outer space. Now, some of it does, but the thicker the amount of greenhouse gases, the more heat is going to be retained. Now, this could be a good thing because otherwise, just like if you're in the middle of a desert and there's no clouds at night, it gets very, very cold. But if it's a cloudy night, it's not so bad. So in some respects, it's a good thing to have these greenhouse gases up here because it's going to keep the planet warm. But too much of anything is a bad thing. So if there's too much greenhouse gases, then the planet is going to be warmer than what we think it should be. So why could the climate of the Earth, why would it be changing? So again, if you go back to the lesson that we had on the ice ages, you're going to find that we're reusing a lot of those explanations. So the first one is that the sun periodically gets hotter and then it gets cooler. And so you can see that it has a 22-year cycle. Okay, then you have the increase in carbon dioxide in the Earth's atmosphere. Okay, so carbon dioxide comes from volcanoes, and it comes from us, animals, and it also comes from power plants and car exhausts. Carbon dioxide is removed from the atmosphere by greenhouse plants, and then it's also removed by the oceans, which turns it into limestone. So the question is, are we putting more carbon dioxide into the atmosphere faster than what nature can remove it? Okay, then there's albedo. So this is the reflection of sunlight off of ice and then back into outer space. So that's going to cool the planet. But if the ice caps melt, that means there's going to be less ice and more land. Land absorbs the heat better than what the ice does. So ice is a good reflector. Land, on the other hand, is a better absorber, and it's not such a good reflector of light. So that's going to make the temperature of the planet even warmer, which is going to cause the ice to melt faster, which is going to make the planet warmer. Okay, so this is a positive feedback loop. Okay, then we also mentioned when we talked about the ice ages about the precession of the Earth, so that the Earth is tilted at 23 degrees, and then this has a 26,000 year cycle that it goes, the precessional tilt is doing this. So just like a gyroscope or a top. But it takes 26,000 years for the Earth's precessional tilt, for the tilt to make one complete precession. Okay, then we also mentioned that the Earth's tilt wobbles. So it's doing this. But this takes 40,000 years to make one wobble. And so this would make the seasons more severe. So if the Earth is tilted like this, then the seasons are going to be less severe. If it's tilted more than 23 degrees, then the seasons are going to be more severe. Okay, then we also mentioned the eccentricity of the orbit of the Earth. Okay, now here's another one that is kind of interesting, that the Earth is in the solar system, and the Sun and the solar system are going around the Milky Way galaxy. But it's not just going horizontal around the Milky Way galaxy. Our solar system, our Sun, is also going up and down, in and out of the plane of the galaxy. So think of a merry-go-round. The horses go up and down at the same time that they're going around in a circle. And so this is a, whenever the Sun is above the plane of the galaxy, it gets extra radiation from the core of the galaxy. So that would make the climate of the Earth warmer. When it's in the plane of the galaxy, it's shielded from the core of the galaxy, and so the planet would get less energy. Okay, then another thing is that as the Sun is going around the Milky Way galaxy, it is going through dust. And then that dust could get in between the Sun and us, so then we wouldn't get as much energy from the Sun, and it would be cooler. And then we also have talked about that the continents, the continental or the lithosphere of the Earth is moving around because of plate tectonics. So occasionally the plates all come together to make a supercontinent, and then sometimes all of these lithospheric plates separate, and then you have separate continents. When the continents are separated, the climate is going to be more moderated. Well, the problem, though, with all of these different cycles is this one has a cycle of hundreds of millions of years. And then this one, again, has a cycle of hundreds of millions of years. And then this has a cycle of millions of years. This one, the one above it, has 100,000 year cycle. Then this is thousands of years. So the only one of all of these different cycles that would cause the climate of the Earth to change in a period of hundreds of years is going to be the carbon dioxide thing. So all of these other ones could be reasons for triggering ice ages, which occur every 100,000 years, but it seems like that the global temperature of the Earth is increasing, and so that seems to be tied to the amount of carbon dioxide in the atmosphere. So, evidence for climate change. So how do we know that the temperature of the Earth is increasing? So one is by looking at pollen from sediment. And so some kinds of pollen really like hot weather. Other kinds of pollen like cooler weather. So we look at ancient sediments, and then from those sediments we look at the pollen and what kind of pollen is it. And so this graph here shows you the abundance of different kinds of pollen. Okay, another one is the isotopes thing. Now this one is kind of tricky because do you remember that when we talked about the ice ages, when an ice age occurs, okay, that's going to draw water out of the oceans to make the ice for the ice ages. So that's going to concentrate the heavier isotopes in the water, which then get incorporated into the shells of organisms. And then when we find those organism fossils in sediments, then we could say that water was being drawn out of the oceans to make the ice ages. But notice that there's a different way of drawing water out of the oceans, and that's evaporation. And so evaporation would occur if the climate got very hot. So notice that this particular technique, looking for the heavier isotopes, could indicate that the climate got very, very cold, or it could indicate that the climate got very, very hot. So you have to be very careful with this particular one, that you combine this information with maybe the pollen stuff to verify that the climate was getting hotter or the climate was getting colder. Okay, then you all know about tree rings, and so tree rings are going to be thicker if it is wetter weather. Tree rings are going to be thinner if it's going to be hotter weather. Okay, another thing is melting ice shelves, melting glaciers. So a glacier is going to retreat up its valley if it gets hotter. Then this one here is the permafrost zone. So permafrost is going to be an area where the ground is permanently frozen at a certain depth. Now above that depth during the summertime it does thaw, but below that is an area where it's constantly frozen, so we call that permafrost. And so the location of where permafrost is seems to be moving further north. So as the climate warms up, then that's thawing the permafrost zones, and so the new permafrost zones are going to be further north. All right, so what are some of the costs of climate change? So if, let's say for the sake of argument, that the climate is getting warmer, then what's it going to do? So the hotter it gets, the more evaporation is going to occur. The more evaporation, the more moisture is going to be in the atmosphere, and then when that cools, the more rainfall that you're going to have. Okay, then you're going to have more heat waves, which means you're going to be using your air conditioner more wildfires. Okay, then there's going to be a change in where you're going to grow your crops. So that some places today that are good for growing a particular kind of vegetable may not be in the future. So you might have to go further north in order to grow that particular kind of crop. Okay, then also rising sea levels. So falling sea levels are going to occur when you have ice ages, and then water gets frozen and it gets pulled out of the oceans in order to make those ice sheets. If the ice sheets melt, then that's going to put water back into the oceans, and the level of the oceans is going to go up, and so that could flood certain parts of the earth. Okay, another thing that could happen is that as all of this fresh water that used to be tied up in the glaciers melts, that fresh water goes into the oceans. And so that could have an effect on global ocean deep water current circulations, because those currents are partially due to salinity differences. And so if you're dumping fresh water into the oceans, that's going to change the salinity of the oceans, and that could affect this. All right, so what is sustainability? Okay, I'm going to skip this. All right, so don't worry about this. So we're going to just skip on through here. And then this would make for a good essay question. So you should be able to, in an essay, explain what you can do to help keep things more sustainable on Earth. So if we want to have the same standard of living that we have today, if we don't want to pollute the environment, if we don't want to have climate change, so if we don't want to do all of this stuff, then what would be some stuff that we can do today? And so here were some suggestions for that. Okay, so that finishes this review for environmental geology. So in our next review, we're going to talk about planetary geology.